So let us now start practicing some integration formulas. We'll start with the integration of powers. So for the formula of integration of powers, we already derived this in the previous video. So we already derived this in our previous discussion. We have the integral of u raised to n du, which is equal to u raised to n plus 1 over n plus 1 plus c. So this is the integration of powers. So let's begin with some examples. So our first problem for this topic, suppose we have the integral of the square root of 3x plus 1 dx. So how would we apply the formula for this integral? So first let us identify the parts of this integral that corresponds to this formula. So we should be able to identify which is our function u, the constant n, and the derivative of the function u or du. So if we look at the given expression, we have a function 3x plus 1 which is raised to 1 half, or yun na yung sa square root. Okay, so how do we identify the parts now? So first we can say that if we let 3x or u be 3x plus 1, it follows that the n here, or the constant to which this function is raised to, is 1 half. Okay, because this is the same as the integral of 3x plus 1 raised to 1 half dx. And the derivative of u, if u is equal to 3x plus 1, the derivative of u is equal to 3 dx. Okay, so if we now reconstruct this formula, then we'll have the integral of u raised to n du. Okay, so we have now in the form a u raised to n du. But notice that this expression is not the same as this, because eto may 3, eto wala. So in order for this to be the same as what we are supposed to evaluate, we must multiply this by 1/3. And since 1/3 is constant, pwede natin ilabas na lang. So meaning, you just need to multiply this by 1/3 for this expression to be the same to the given expression that we need to evaluate. Okay, then from here, we can now readily answer that the integral of yung given natin is equal to 1/3 times the integral of u du is equal to u raised to n plus 1 over n plus 1 plus c. So therefore, we just follow that formula. So therefore, that is 1/3 times the integral of this is u raised to n plus 1. So that would be 1 half plus 1. That's 3 halves over 3 halves, or n plus 1. Then plus c. Okay. So our final answer would be 2 over 9 3x plus 1 raised to 3 halves plus c. So this is our final answer. For our next problem, suppose we have the integral of cosine x dx over sine raised to 4x. We could actually rewrite the function as the integral of sine raised to negative 4, or sine x raised to negative 4 times cosine x dx. So from here, we could say that this is our u, and this is n, and this should be the derivative of u, because if we let u be equal to sine x, it follows that n is equal to negative 4, and du is cosine x dx. Okay, so the function now is in the form u raised to n du. So therefore, the integral of this, or the answer for this integral, is equal to u raised to n plus 1. So that would be negative 4 plus 1. So it's negative 3 over negative 3 plus c. So we could rewrite our answer as negative 1 over 3 sine cube x plus c. So this is our answer. For our next problem, we have the integral of cosine 2t dt all over the quantity 1 plus sine 2t raised to 4. So if we rewrite the integral to the integral of 1 plus sine 2t raised to negative 4 cosine 2t dt, we could readily identify u as 1 plus sine 2t and n as negative 4. Okay, so it follows that du is equal to the derivative of this, which is 0 plus derivative of sine is cosine 2t times the derivative of 2t is 2 dt, or that would be 2 cosine 2t dt. So if we reconstruct the integral of u raised to n du, that would become the integral of u raised to n du, and this is not the same as this because dito meron siyang constant na 2, dito wala. So in order for us to eliminate this, we need to multiply this by 1/2 so that this expression will be the same as the given expression. Okay, then from here, this is now equal to 1/2 times the integral of u raised to n du, and the integral of u raised to n du is just equal to u raised to n plus 1 over n plus 1 plus c. So therefore our answer is equal to negative 1/6, or negative 1/6 times 1 plus sine 2t raised to negative 3 plus c, or if to be consistent with the given, that would be negative 1 over 6 times 1 plus sine 2t raised to 3 plus c. That is our answer. So now let us proceed to our next formula, which is the formula for integrals that results to a logarithmic function. So we know that from derivatives that the derivative of ln u is equal to du over u. Okay, so therefore if we apply antiderivative both sides or integration both sides, we could say that the integral of du over u is equal to ln u. Then we just add an arbitrary constant c. So this is our formula, second formula. Okay, let's start with this problem for this formula. Let's solve problem number 11. Evaluate this integral of x dx over 1 minus x squared. So if we rewrite this into integral of 1 minus x squared raised to negative 1 times x dx, you notice that n is equal to negative 1, so therefore the power formula cannot be used. And if you notice, if we let u be 1 minus x squared, du is negative 2x dx, or du is a du is a first degree equation or expression. Okay, so here the numerator is also first degree, so similar sila. So therefore this is a case of the integral of du over u. So if we reconstruct the integral of du over u, then we'll have integral of du, which is negative 2x dx, over u, which is 1 minus x squared, which is not the same as the given integral. So in order for this to be the same as this, we need to multiply this by the constant negative 1/2. Okay, para kung cancel natin to, then this is the same as this. Okay, so therefore our answer here is negative 1/2 times the integral of this, which is just integral of du over u, which is simply ln u. So u here is 1 minus x squared, and remember that u cannot be equal to a negative value because we cannot apply logarithm to a negative value. Okay, so plus c, or dapat wala ng bracket, that's negative 1/2 ln the absolute value of 1 minus x squared plus c. Okay, you can also rewrite this in another form because ito siya, we know that that could be written as an exponent. Okay, so, or we could stick to this as our answer. Okay, suppose we have to evaluate the integral of this function. So how would we answer this? So again, the denominator is a third degree polynomial, and the numerator is a second degree polynomial. So therefore, the numerator is similar to the derivative of the denominator. So this is a case of du over u, or integral of du over u. So if we let x cube, or no, if we let u be equal to x cube minus 6x plus 2, then du is equal to 3x squared minus 6 dx. Okay, then actually if we factor out 3, then this would be x squared minus 2 dx. Okay, so therefore if we reconstruct again the integral of du over u, then we'll have the integral of du which is 3 times x squared minus 2 dx divided by x cubed minus 6x plus 2, because this is our u. Now, comparing it to the given, this is not the same as this because of the factor 3, so we multiply this by 1/3. So therefore, this is now 1/3 times the integral of du over u. And the integral of du over u is just ln u, which is x cubed minus 6x plus 2 plus c. So that is very easy. So for problem number 13, let us evaluate the integral of x plus 3 over x minus 1 dx. The first and the numerator and denominator are both has the same degree. Pareho silang linear or first degree. So therefore, in this form, the numerator is not similar to the derivative of the denominator. Diba? But since we are dealing with fractions and the degree of the numerator and the denominator are the same, we could just divide the two. Diba? Let's just proceed with division. So, dalawa yung pwede nating option dito. We could do long division and we could also do some manipulation na lang. So, if we do long division, it would be like this. We divide x plus 3 by x minus 1. And that would be 1. So, x minus 1, 4. So, the result is 1 plus 4 over x minus 1. So, that would be the quotient. Okay? Pero rin naman, we do it like this. Manipulation na lang. Pwede rin, dire-diretso na natin ganitohin. Okay. The denominator is x minus 1. So, I want x minus 1 to appear in the numerator. So, ilagay ko dito x minus 1. Then, remember that the numerator is x plus 3. So, what number should I add to x minus 1 so that the result is x plus 3? Of course, we need to add 4 because x minus 1 plus 4 is x plus 3 dx. Then from here, pwede na natin i-separate. So, ito, that is equal to 1 plus ito, which is equal to 4 over x minus 1, which is the same as this if we do long division. Okay? So, pag mga ganitong klaseng polynomial, tag first degree lang, numerator and denominator, pwedeng manipulation na lang. So, from here, we just need to get the integral of this plus the integral of this, then that's our answer. So, I'll just rewrite this as integral of dx plus 4 integral of dx over x minus 1. So, the integral of dx is just x plus 4 times the integral of this. Remember that if u is x minus 1, du is just dx. So therefore, this is simply du over u, or the integral of that is ln u, which is ln x minus 1, then plus c. This is our answer. Okay, let's try this other problem. Problem number 14. Evaluate the integral of x plus 6 dx over x plus 2 squared. Okay, notice that the denominator is second degree, the numerator is first degree. So, pwede siya, diba, d over u. Pero how do we manipulate this? The derivative of x plus 2 should only be dx, diba? And since mas maliit yung degree ng numerator than the denominator, so huwag na tayo mag-divide, diba? Pero if we apply yung technique na ginawa natin dito, wherein we just manipulated the expressions, pwede natin isulat siya ng ganito. Okay. X plus 2 squared, or x plus 2, this factor, x plus 2, appeared in the denominator, at the denominator. So how about if I write that as a numerator? So what number should we add to 2 or sa x plus 2 para maging x plus 6? Of course, we need to add 4. Okay? Then if we do that, the result would be this, diba? So x plus 2 over x plus 2 squared, that would be 1 over x plus 2. And then plus 4 over x plus 2 squared. And then dx. So from here, pwede tayong mag-solve, diba? Because this will become the integral of dx over x plus 2 plus 4 times integral of dx over x plus 2 squared. So the first term is an ln integral, diba? Because this, if this is u, du is simply dx. So this is integral of du over u. So the integral of du over u is ln u. Okay? Then plus 4, how about here? Dito, naka-square na siya. So if this is our u, this would be u squared. So if we let u be equal to x plus 2, then du would be dx. Pero may square siya dito, so therefore, di siya equal to negative 1. Therefore, this is not an ln integral, or du over u na integral. This is power of formula ang gagamitin, or integration of powers, because this would be the same as the integral of x plus 2 raised to negative 2 dx, wherein n is negative 2. Okay? So this would be 4 times u raised to negative 2 plus 1. It would be negative 2 plus 1, so that's negative 1 over negative 1 plus c. So our final answer is ln x plus 2 plus 4, no, that would become minus 4 over x plus 2 plus c. Okay, hindi na nakita. X plus 2 plus c. Yan. So this is our answer. Okay, as your assignment for this video, you send me the answer for this integral. The integral of dt over 1 plus t squared times t. So just send it as soon as possible through PM na lang. So that's it for our lesson. I'll see you in the next topic.